Top 3 points for interview process. Number 1. Under the manufacturing excellence. First, we need to understand the autonomous maintenance and its steps. Number 1. Step 0. Safety. Number 2. Number 1. Initial phase cleaning as red tail and white tail. Number 2. Steps. Measure against the source of contamination hard to access area. Number 3. CLID. Number 4. Overall inspections. Number 5. Standardizations. Number 6. Autonomous maintenance. Number 7. All about the management objective. These all are the 7 steps of autonomous maintenance which we need to be understand, and this is very much important to implement the autonomous maintenance in plant. Under this, operator need to be maintained and take care of their own machines, and only engineering person can focus on the developing all the things for betterment of the lines. Second, preventive maintenance steps under the TPM. Step 1, daily measures. Number 2, periodic maintenance. Number 3, service life extensions. Number 4, spare part management. Number 5, failure analysis and reoccurrence preventions. Number 6, lubrication management. These all are the 6 steps is very much important from the preventive maintenance, by which we can reduce the breakdown over in the plant. This is very much important to know for each and everyone who's the working professional and belong to manufacturing process. Number 3, Kaizens and Kaizen steps. Number 1, Kaizens required whenever any kind of the modification or any kind of the problem which required to solve with the right kind of the kappa, and as a kappa result we need to take the certain kind of the Kaizen for the eliminations or reduction of the problem, which come under the 3 pillars, focus improvement pillar of TPM, and this consists total 12 number of steps. Step 1, identification of the losses. First we need to understand what is the losses is going on and what is the impact of this one. Number 2, selection and justifications. The second step is very much important as a selection and justification of the equipment and the problem. What is the problem and why this happened? This come under the justifications. Number 3, understand the process and equipment. Before any kind of the result, first we need to be understand what is the process going on, what is the equipment was involved in this entire process, and what kind of the problem came in this during the running process. Number 4, grasp the actual situations, and during this we also need to be put the same kind of the situations which happened during the running batch or running machines operation, and which caused the major breakdown in the process. Hence, grasp the actual situation for better understanding of the real cause. Number 5, establish the objectives. After the grasp the actual situation, we need to establish the objective. What is our requirement from this entire exercise? Number 6, make a plan, and on the basis of the objective, we need to prepare a plan. Why, when we are going to be complete this task, whose people going to be involved in this, and what should be our strategy. Number 7, we also need to perform the cause analysis based on all the 6 steps. What was the happened, why was the happened, how was the happened, kind of. Number 8, propose the countermeasures. Basis on the findings, we need to propose the countermeasures that after implementation of this problem will not occur in upcoming future. Number 9, carry out the countermeasures, and after propose the countermeasures, we need to be carry out the countermeasures for the elimination of these problems. Number 10, verify the results. After implementation of the countermeasures, we need to verify the results. What are the results came, and is it in line with our expectations or not? Number 11, standardizations. When our results in line with our expectation, this has to be standardized for all the sections, all the lines, not only for in single plant but other plants also. Number 12, future plan. And with respect to this standardization, which is the 11th step, and last step is the future plan, which mentioned the what kind of the technology which we are going to be adopt in upcoming future for the elimination of the such kind of the problem permanently. So these all are the 12 number of pillars of process improvement under TT. These are the very much important. Now we are going to be discuss about the 5S. 5S is very much important and it's the base foundation of the TPM. Under each consists the 5S means number 1 seri means order, sit-on means arrangement, siso means cleaning and shining, sitsu standardization, sitsu set discipline. That means seri, sit-on, sisu, sitsu set. It's a 5S means order, arrangement, cleaning, standardization and discipline. This talk about the 5S philosophy. Now next point, ECRS. ECRS. E means eliminations, C means to combine, R means to replaceable, S means simplify. Any kind of the problem which we want to be eliminated, we need to be focused on ECRS. First, our objective for the elimination of this problem. Number 2, if this is not possible, then we need to be combined this problem to other identified problem which also not going to be eliminated. Number R, if possible, we also need to be take the call for the replaceable. And S, if simplify can provide our answer, then we also need to go for the simplify. That means ECRS, eliminations, combine, replaceable, simplify. Major cause of breakdown. Next point, dust, dirt, contaminations, looseness, leakages, excess heat is the major part of breakdowns. And breakdowns is also divided into two parts. First, breakdowns due to the aging effect. Second kind of breakdown due to the deterioration of the due to the natural deteriorations. Then natural deteriorations and deteriorations is also divided into two parts. First, forced deterioration. Second, natural deterioration. Forced deteriorations which lead the machines by force. Due to some negligence, due to some kind of the unoperational conditions, these machines come into breakdown. This is known as forced deteriorations. Natural deteriorations come with the aging effect of the line, where we need to be take the service life extension kind of project, and by which we can eliminate, which can reduce and reduce the losses along with the service life extension of the lines or equipments. These are the some major process of breakdowns. Now, total 16 losses, total 8 losses in manufacturing. Number 1, breakdown. Number 2, setup and adjustment. Number 3, utility tools replacement. Number 4, startup loss. Number 5, speed loss. Number 6, quality defect. Number 7, shutdown. These all are the major 8 losses which we need to be understand for the manufacturing process. Now, what is the 5W burn H? 5W burn H means W1 what, W2 why, W3 where, W4 who, W5 when, then 1H means how, what, why, where, who, when, how. This is the complete combination of the 5W1H. Now, TPM analytical tools, YY analysis, WWBLA, PM analysis, ECRS, SMED and FEMA. Now,
MTBF, मीन टाइम बिटवीन फेलियर, दो ब्रेकडाउनों के बीच का जो समय होता है उसको हम MTBF बोलते हैं. और MTTR, मीन टाइम टू बिटवीन रिपेयर, मशीन को सही होने में कितना समय लगा उसको हम MTTR बोलते हैं. MTBF का जो फार्मूला होता है वो होता है टोटल नंबर ऑफ ऑपरेशन आवर डिवाइड बाई टोटल नंबर ऑफ फेलियर्स. और MTTR का जो फार्मूला होता है वो होता है टोटल रिपेयर टाइम डिवाइड बाई टोटल नंबर ऑफ रिपेयर्स. तो ये हमारा फार्मूला होता है। इसमें MTTBF भी आता है, जिसका फार्मूला होता है टोटल नंबर ऑफ ऑपरेशन आवर्स डिवाइड बाय टोटल नंबर ऑफ एसेट इन यूज़। ये हमारा MTTBF में आ जाता है। हाउ टू इम्प्रूव MTBF? A well-planned preventive maintenance program can significantly increase your MTBF. When it comes to maintenance, whenever you can be proactive rather than reactive, you have to be better chance of preventive failures. A badly implemented preventive maintenance program can actually reduce MTBF. Quick breakdowns can be caused by lack of training, a lack of properly prepared manuals and checklists. Understanding why something went wrong is the key to prevent it from happening again, or at least not as a frequently basis. Root cause analysis, similar to the preventive maintenance, can boost MTBF indirectly by identifying a long-term solutions. And we need to understand what is the formula of the MTBF. MTBF formula is total number of operational hours divided by total number of failures. What is the MTTF? MTTF, mean time to failure. The mean time to failure, or MTTF, is a measurement of how long it takes for something to fail. This is a device average life expectancy. The mean time to failure is derived by multiplying the device lifespan by the number of devices. The average output of time a non-repairable assets operate before failing is measured by the mean time to failure, MTTF, because MTTF only applies to asset and equipment that cannot or should not be fixed. It's often referred to as an asset average lifespan. MTTF applies to non-repairable assets which are replaced when they fail. There are a variety of reasons why an asset might not be fixed, but the most typically argument is that replacing the asset is less expensive and takes less time. This is important. This is very important. Some of the example of this kind of the equipment like transistor, fan belt in motors and engines, idler valves, rollers, conveyors belt, forklift wheels, light valves, etc. is the part of this one. Now, how to calculate the MTTF? The MTTF formula is total number of operational hours divided by total number of asset in uses. This is the formula of MTTF, mean time to failure. Now, we are going to be discuss about the we have discussed about the MTTF, and similarly we have already discussed about the MTBF. Now MTTR, what is the mean time to repair? MTTR is the acronym that stands for mean time to repair, means time to recovery, means time to resolution, mean time to resolve, mean time to restore, mean time to reply. This is very much important, and MTTF is very much has to be in less, because if it is going to be high, the number of breakdown going to be increase in this case. How to calculate the MTTR? There is a formula: total repair time in hours divided by total number of repairs. This is the formula of MTTR. Loss matrix: classification of the sustained losses in manufacturing excellence. It also known the Pareto loss matrix in TPM. Here is a total 16 number losses, which is capture the various loss in the productions during the manufacturing operations. It is divided into three parts: number 1 availability losses, number 2 performance losses, and number 3 resource and consumption losses. Here further availability loss is divided into eight losses. Under this, first loss is breakdown loss, second setup and adjustment loss, third tools change loss, fourth startup loss, fifth minor stoppages loss, sixth speed loss, seventh defect and rework loss, and ninth shutdown loss. These are 9 losses which come under the availability losses. Now second is performance loss is further divided into 5 parts. Number 1 management loss, number 2 motion loss, number 3 line organization loss, number 4 distribution loss, number 5 adjustment loss. Now third resource and consumption losses. This is the third part of third sections of the total 16 losses in productions. Under this resource and consumption losses, first is energy loss, second is consumables loss, and fourth and third one is yield loss, which is very much important. So all these losses is very much important, and for elimination of and the better control on cost and wastage, we have to be focused on these all 16 losses, because all the losses which are well defined under the 16 losses theory under this Pareto losses, and this is very much important to know the what kind of the losses is stated to us, by which we are not able to get the required efficiency of the lines, required cost and required quality of the product. These are very much important. What is the preventive maintenance, and what kind of the preventive maintenance which is divided? Now, what is the preventive maintenance? We need to understand this one in these sections. The preventive maintenance is the act of the performing regularly scheduled maintenance activities to help prevent unexpected failure in the future. But simply, it's about the fixing things before they break, and this is very much important for the for the elimination of for or reduction of the any kind of the sudden breakdowns in the operations in equipments or machines. How does preventive maintenance work? So, machines learning, operational data analytics, and the predictive asset health monitoring engineers can optimize the maintenance and reduce the reliability risk to plant business operations. This is very much important to prevent our machines from the sudden failure, for which we need to be carried out different kind of the equipment checks, part check, assembly check during the preventive maintenance at the schedule basis. Now, types of the preventive maintenance. There are the four types of the preventive maintenance. Each is built around the concept of the plant maintenance, although they are all organized and scheduled differently to suit the different business operation purpose. Number one, uses-based preventive maintenance. Uses-based preventive maintenance is triggered by the actual utilization of the asset. Why this type of the maintenance takes into account the average life uses or exposure to environmental condition of an assets. Use it to forecast a due date or for a future inspection or maintenance task. Second, calendar/time-based preventive maintenance is the TPM conditions. It's a time-based preventive maintenance. Calendar/time-based preventive maintenance occur at the scheduled time based on the calendar intervals. The maintenance action is triggered when the due date approaches and necessary birth orders have been created in the systems. Third one, predictive maintenance. Predictive maintenance is designed to schedule corrective maintenance actions before a failure occurs. The team needs to first determine the condition of the equipment in order to estimate when maintenance schedule be performed. Then maintenance tasks are scheduled to prevent unexpected equipment failures. Fourth, prospective maintenance or condition-based maintenance. Prospective maintenance does not just show that failure is going to be happen and when, but also why it is happening. This type of the maintenance help analyze and determine the different option and potential outcomes in order to mitigate any risk to operations. This is very much important that condition-based maintenance to have to be happen in the plant, and under this now in the electrical system we are using the thermography kind of equipment by which we can easily identify the any kind of the loose connections or heating in the electrical system which may create the with losses. These are the preventive maintenance schedule maintenance kind. That's